Okay, I want you to imagine a computer that doesn't just process information, but one that explores every single possibility, all at the same time. I know, it sounds like science fiction, right? But that's the very real promise of quantum computing. We're talking about a leap into a totally new reality of processing power. And today, we're going to break down exactly how it works. So let's just start with the big, weird question right at the heart of it all. How can a computer possibly be in two states at once? I mean, it seems to defy all logic, doesn't it? But, leaning into that question, embracing that apparent paradox, that's the very first step to understanding the incredible power hiding in the quantum world. And to really get our heads around this quantum leap, we've got to start with the absolute fundamentals. The real difference, the digital divide, if you will, is all about the language these computers speak. It's a tale of two units, the bit we all know and love versus the game-changing qubit. So think about the phone in your pocket or the laptop you're on right now. It runs on bits, billions and billions of tiny little switches that are either on or off, a 1 or a 0. That's it. It's a super simple, reliable system that, hey, built our entire digital world. But a qubit? Oh man, that's a whole different beast. The best analogy is a spinning coin. While it's in the air, spinning, is it heads or tails? Well, it's kind of both, and neither. It exists in this fuzzy state of pure potential. That is a qubit. And that one little difference is where all the magic begins. Okay, so we've got this wild spinning coin. How do we actually harness its power? Well, it all comes down to two, frankly, mind-bending principles of quantum physics. These aren't just cool features. They are the literal engine of a quantum computer. First up, superposition. This is just the fancy scientific name for our spinning coin idea. Because a qubit can be a 0 and a 1 at the exact same time, a handful of them can explore millions of potential solutions to a problem simultaneously. A regular computer, it would have to check each possibility one by one by one. This isn't just a small speed boost. We're talking a massive exponential leap in processing capability. But superposition is only half the story. The second superpower is, believe it or not, even weirder. It's called entanglement. Imagine you link two of those spinning coins in a special way. The very instant one lands on heads, you know instantly that the other one is tails. It doesn't matter if it's a foot away or on the other side of the universe. Einstein himself called it spooky action at a distance. And this bizarre, spooky connection lets qubits work together in perfect harmony, creating a computational powerhouse that is just unlike anything we have ever built. So, we've got these incredible quantum properties, superposition and entanglement. This is way more than just a fascinating physics experiment, though. This is the key to finally unlocking solutions to some of humanity's most difficult, most stubborn problems. Look, the potential here is almost hard to wrap your head around. Let's talk about medicine. A quantum computer could simulate a new drug molecule in perfect, intricate detail, letting us see how it will work before it's ever even made in a lab. You know what that means? It could slash the time to develop life-saving medicines from a decade down to maybe just a few months. Or in finance, it could untangle the most chaotic market dynamics imaginable, from creating truly unbreakable codes to designing new materials atom by atom. This isn't just about faster computers. This is about finally being able to solve problems that right now, for us, are simply unsolvable. Now, this all sounds absolutely amazing, and believe me, it is. We're standing right on the edge of a new technological revolution. But it's also really important to remember that this whole journey is just getting started. Yeah, we are still in the very early days. You see, qubits are unbelievably fragile. They're so sensitive that the tiniest vibration or change in temperature can mess up a whole calculation. Building a big, stable quantum computer is truly one of the greatest engineering challenges of our time. But make no mistake about it, the race is on. And even with all those challenges, the goal is crystal clear. Quantum computing isn't just about building a faster gadget, it's about forging an entirely new tool to help us understand the universe itself. This is a technology that really does promise to redefine the very limits of what we consider possible, which, leads us to the ultimate question. Once we have a machine that can solve problems we currently label as impossible, what are we going to ask it? What incredible discoveries are just sitting there, waiting for us, right beyond our current limitations? The quantum future is still unwritten, but one thing's for sure, it's going to be an incredible story.